let's have a look at Leaving Cert, question 12B from 2011. Again, this is one of these half questions which are very popular. 28 marks altogether. Should take you a maximum of 10 minutes to do this question. So let's have a look at this question in your notes. So they're asking me in 12 part B to state the laws of refraction of light. So have a look at these in your notes. But they come in two parts. The first part would be Snell's law. Now you can write down, if you want, you can write down Snell's law as a formula. You can write down for first part of the laws of refraction, sine I divided by sine R is equal to a constant. You could also say that in words if you want. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. If you do write down the formula for that, you should write down what I stands for. Angle I is your angle of incidence. And angle R is your angle of refraction. So anytime you write down a formula for a definition, you should write down what we call the notation, what the letters in the formula stand for. Then the other one is, part of this, is the incident ray, or the incident wave, the refracted ray, or refracted wave, and the normal all lie in the same plane. So I explained what that meant during one of the lessons. All lie in the same plane. So there's going to be 3 marks for each of those. So it's very important to remember that second part there. It's not just Snell's law, it's Snell's law plus this thing about them all lying in the same plane. Let's go on to the next part. The next part says, a lamp is located centrally at the bottom of a large swimming pool, 1.8 meters deep. Draw a ray diagram to show where the lamp appears to be as seen by an observer standing at the edge of the pool. So we did this in one of our lessons where we were talking about a real depth and apparent depth. So remember, when you look into a body of water, the objects appear shallower than they actually are. So you should know how to draw this diagram. So here's my diagram here of a pool of water, and there's the object at the very end. That object will appear shallower than it actually is to an observer outside the pool. So how do we go about drawing it? Well, this here is my object O. Draw a line, a normal if you like, straight up like that. In order to form an image, I need 2 rays of light. So let me take 1 ray of light, and there are millions of rays of light coming off that object. Let me just take one of them. So here's one ray of light. What happens? Well, it's moving from a slower medium into a faster medium. Let me put the normal in here, which is a line perpendicular to the boundary. What happens when it moves into a faster medium? It'll bend away from the normal like this. Here's my first ray of light. You should just continue that down to that central line there. Anyway, in order to form an image, I need a second ray of light. To take a second ray of light, so let's say I take this ray of light here. And what happens when it comes out? Well, once again, put your normal in. So here's my normal. It's going to bend away from the normal. You don't have to do any calculations with protractors. Just put your ruler like this. So put your ruler in a line like this. It bends away from the normal. And if I work that back, those rays of light will meet there. So the observer outside the water, those two rays of light are diverging. They're never going to meet, but in someone's mind's eye, they can work them back to where they meet. And if I work them back, they meet at this point here, and there's my image I. And you know all about the real depth and the apparent depth. The real depth is the full depth of the pool, and the apparent depth is from the top to where the bottom appears to be. So 7 marks for doing that diagram correctly and showing where the image is. Last part of the question. They're not very long, sure they're not. So the last part of the question, they're saying to me, at night, when the lamp is switched on, a disc of light is seen at the surface of the pool. Explain why the area surrounding the disc of light appears dark. And then they want you to calculate the area of the illuminated disc of water. So let me explain what's going on here. So you've got millions of rays of light coming from your object at the bottom of the pool. And if the angle of incidence is smaller than the critical angle, that light will escape. But you will get to a point where the angle of incidence is the critical angle. Let's say this ray of light here. Here's my normal. And let's say that angle of incidence there is the critical angle. Well, that light will not escape. The angle of refraction will be 90 degrees. If you go beyond that, then the rays of light will bounce back into the pool. So they won't emerge to be seen. Go on this side as well. Everything inside this disc here, the light will escape, and you will see that disc of light. This here, here's my normal. There's your critical angle. That ray of light will just go along the surface. It won't escape to somebody's eye. So anything to the left and right of those normals will appear as dark. So they're asking me the question, why does the area surrounding the disc appear dark? Because light does not escape. I suppose we could say due to TIR, but don't write down TIR, write down the whole thing. Due to total internal reflection. So anything to the right and left of those normals gets bounced back into the water and doesn't emerge, so it'll appear dark outside the disc. So there's 15 marks altogether for this, so 3 marks for this part here. The important thing to say again is total internal reflection is what they're really looking for in this answer. Now the rest is going to be mathematical, so we're just going to use a number of formulae. So they're asking me to calculate the area of the illuminated disc of water. That's a circle there. And here's the radius of my circle. And in here, I've got a right angle triangle. They're going to do a little bit of trigonometry. The first thing I need to find is, I need to find that angle C. So I've got to write down a formula. You'll get 3 more marks now for writing down the formula. So the formula that I'm going to use is that the refractive index n is equal to 1 over sine c. So that will give you 3 more marks. I want to write down that formula in terms of c. Slide the sine c up and the n down. So sine c is 1 over n. And therefore the critical angle c is equal to the inverse sine of 1 over n. So that will be the inverse sine of, they have given me at the end of the problem, they've given me the refractive index of water. They're telling me that the refractive index of water, NW, is equal to 1.33. So we're talking about the inverse sine of 1 over 1.33. So put that into your calculator. And when I put that into my calculator, so shift, sine, fraction 1 over 1.33, close bracket, and I get, say, 48.75 degrees. I've got the critical angle C is equal to 48.75 degrees. That's your first step. Now, my next step is I want to find the radius r, and then I can use my area of the circle. What's my area of the circle? Pi r squared, to find the area of that illuminated disk. Well, first of all, some simple geometry. Alternate angles. If that's C there, that's C down there. So this angle here is C. Now, we know what the depth of the pool is. We know the depth of the pool is 1.8 meters. So this line down here is 1.8 meters. So let's use some simple trigonometry for right angle triangles. I'll use tan. Tan C is equal to the opposite, which is r, divided by the adjacent, which is 1.8. That implies r is equal to, slide the 1.8 up, 1.8 times tan C, and C is 48.75 degrees. So I'll put that into my calculator, and now I've got the radius. So every step you do here, you're getting 3 marks for. And you'll be doing these calculations with me. Don't be watching me doing them. There's no better way to learn than to be doing the calculations with me as you go along. So I get, say, 2.053. Yeah, I'm being generous with my number of decimal places until I get to the final answer. Meters. Right, so finally I want to get the area. So the area of the disk, well, I can use the area of a circle, is pi r squared. So that's pi times 2.053 squared. And that would be my final answer. So it's actually a nice problem. Tricky enough. And they ask it quite a lot. But look, once you do 1 or 2 of them, you'll be absolutely fine. You'll know the technique. So let me get pi multiplied by 2.053 squared. And I get, say, 3.24. And of course, write down your units when you're finished. Always get into the habit of this. And the units are meters squared. Okay, that's a nice question. There was a nice little problem in that question.